Point 4, volume and capacity of spheres, cones, and pyramids. Hopefully you just saw that video where we developed these right here. And those are the volume formulas. One thing we need to understand is this conversion right here. Okay, so if we're looking at a cube that's 1 meter by 1 meter by 1 meter, that's going to be 1 meter cubed, isn't it? 1 times 1 times 1 is 1. But if you write that in terms of centimeters, this would be 100 centimeters times 100 centimeters times 100 centimeters. So 1 meter cubed is actually 1 million centimeters cubed. Okay? Because 100 times 100 times 100 is 1 million. Okay? So 1 million centimeters cubed is equal to 1 meter cubed. Now, if we're talking about a length, 1 meter is equal to how many centimeters? 100. So if we're talking about a length, but if we're talking about a volume, that's by a factor of 3, so it's going to be 100 times 100 times 100 is 1 million. So, therefore, if you have a certain number of cubic meters, you have to divide this by 1 million if you want to get cubic centimeters. Or, sorry, multiply by 1 million to get cubic centimeters. If you have cubic centimeters, you need to divide by 1 million to get cubic meters. Okay?
Can you say that again?
Yeah, if you have cubic centimeters like this one, you want to divide by 1 million to get cubic meters. If you have cubic meters, you have to multiply by 1 million to get cubic centimeters. Because this is 1 cubic meter is the same as, equal to, 1 million cubic centimeters. Okay, so I don't know if we need to go through this example. Let's just go right to the build your skills question.
Is it question 1? Did you do question 2?
Nope, we're going to do question 1. Find the volume of each sphere. Okay, so a sphere with radius of 8.5. Well, this should be pretty easy. And maybe you asked me to do a different one because you've already done this one. Is that correct?
No, just because if you look at question 2 after all.
It's question 2 stuff? We'll maybe look at it later. So here's a sphere, and I'm just going to write down the radius is 8.5. So if you remember your volume formula, it's 4/3 times pi times r cubed. Or another way to put that is this way. 4 times pi times r cubed, all divided by 3. And this might be actually easier to put into your calculator. Right? Might be. So the volume of this one is actually going to be 4 times pi times 8.5 cubed, all over 3. You might have a little trouble finding your cubed button on your calculator, depending on what calculator you're going to use. So all of you will have some kind of exponent button. It may be a little hat like this one, or it may be like a y to the power of x, or something like that. Don't use the exp button. That's scientific notation. So what I'm going to do here is I'm going to show you how I would do this. 4 times pi times, okay. Now I'm going to use some brackets here because I just want to cube the 8.5. So I'm going to use brackets there. And then I have a little exponent button to the power of 3. So everyone find your exponent button there. And then you close the brackets and divide it by 3. And it looks like this is what you should get right here. Okay, so everyone make sure you can do that on your calculator for me. Okay, so 2,572, 0.44, if you had that, that's great as well, or 0.4, okay. So that's 1A, 1B is very similar. Yeah, okay, let's take a look at number 2, because this is kind of tough, right? So let's take a look at number 2, but what you have to do is just picture this as 2 different spheres. So a sphere with a radius of 46 centimeters is centered inside a sphere with a radius of 76. So this little one is 46, and the bigger one is 76. So we have 2 spheres. The question is, what is the volume of the space between the 2 spheres?
Would you find both the volume and subtract the big one?
Yeah, that's all you do. You find the volume of the big one, you subtract the volume of the smaller one. That's all you do. So it's like two separate problems, right? This is the big one is 76 radius, the little one is 46, okay? So that's what you do for 2A. Okay, I'll give you a few minutes to work on questions 1 and 2. And then we'll move on to this example here. So finish 1 and 2. Okay, so if we look at page 185 together, we're talking about volumes and capacities of pyramids. So again, we took a look at what the formula for volume of a pyramid was, and that was the area of the base times the height from the top to the middle of the base there, that height, not the slant height, but the overall height, and then we divided that by 3. And again, that we did that when we found these in that video we just did, lesson we just did. So, yeah, it's as simple as this. If we have a pyramid that looks like this right here, it's as simple as 18 times 15 times 25 here, the height, and then divide that all by 3, and you get your volume. Okay? If we want to convert that to capacity, as long as we're in centimeters cubed, right, we just divide by 1,000 to get liters. So centimeters cubed divided by 1,000 gets us liters. Just remember that. All right, so in the build your skills category here, let's do number 1 together. This is super easy. What's the area of the base? Well, that's going to be 15 times 17. So we got 15 times 17. And then the height, which was 19 here. The height is 19. So we multiply by 19. And then we divide that by 3. Okay, so we get out our calculator. And we do 15 times 17 times 19 equals, divided by 3. Now you don't have to do equals in between, but I like doing that just to kind of separate the top and the bottom a little bit. And 1615, 1,615, and that's going to be, oops, what's my units there? Inches cubed. Okay, remember volume is always in cubic units, and use the units that are in the question. Okay, so B is very similar. Oh, let's take a look at C. So C is just two pyramids stuck to each other, right? So if you find the area of one pyramid up top here, right, find all that area inside, what you can do is just multiply it by 2, and you get the area of the rest of it. The volume of the rest of it. Okay? So, how would we start this one? Well, the volume of this shape is going to be the length of the width of the base times the width of the base times the height of one of the pyramids divided by 3, and we're going to do that times 2, twice. See that? So we've got, what do we have? We've got 9.8 times 4.3. So 4.3 times 9.8. And what's the height? 6.2. And we're going to divide that by 3, and then we're going to multiply all of that by 2. That should be your volume. So go ahead and finish that one off there. Oh, just wait a minute here. It appears that they are not the same height, are they?
No,
I don't think I saw that. This one is 6.2. Is that a height there? And then this one's 4.8. Oh, that's kind of misleading. This one actually looks longer than this one. Okay, so back off here. Back right off. We have to solve these separately because they are not the same. I'm sorry, I thought they were the same. So let's do volume 1, which is going to be the top volume, because we've got 6.2, and then I didn't notice it's even in smaller font and everything. That's really tricky. Okay, so you got to be careful there, I guess. So look carefully. Yeah, it's true. It is 4.8. So then the volume of the bottom pyramid is going to be still 4.3 times 9.8, but we have this now height of 4.8 instead of the 6.2 we had before, and divided by 3. So that's going to be volume 2. Okay, so we do have to find this one, and then we have to find this one, and we add those together, okay, for our final answer. So, do you guys have answers for these two? Yeah? Anybody have volume 1? Anybody do this one? Yeah, what'd you get?
87.08.
Okay, good, 87.08. Anybody do the second one yet? Yeah?
202.27.
No, is that the total? Is that the total? I think check that again, because this one should be a little bit less than 87.
67.24.
What'd you get there, Jaden?
67.4.
That is correct. 67.4. Right, so then we add those two up and we should get about 154.5. Okay? And that's going to be centimeters cubed. All right, so just by the look of that, it looked like those two pyramids, the top one and the bottom one, were equal, but they weren't upon closer inspection. And you have to find the two volumes and add them up, right? All right, no problem. Okay, so what I'm going to do here now is I'm going to give you time to go ahead and finish all of the questions 1 to 5. You can go back if there's any that you didn't quite get, and you'll have to work on these ones as well. And then we'll probably stop there for the day.